Hello YouTube. In this video, I will show you some video games made by a blogger post. So just make sure this is a blogger. It's a XYZ code bloggerspot.com, and you go to games and check out this post. Pawn. Here's your arrow key. You can move your board and reflect the ball. And this video game is made by this code, source code, with style sheet and some kind of JavaScript, um, a few dive, and this is a source code you can copy paste to your blogger post's HTML, and it will be able to play that game. You can even be able to make video games just by CSS, no JavaScript, like this game. Just shoot those, use your mouse to shoot those birds. Okay, yeah, you're dead. Have you dead? Come on, come on, come on, come on. Yeah, kill this, kill this. No, this is a tough bird. Oh, game over. And my score is 5, and I can restart the game. So let's check out the source code. Let's include a style sheet and some dive. There's no JavaScript, so that's a pure CSS video game. Okay, and what I want to show you is you can even study Java code by playing video games. Here is a video game, show you just help you study Java collection framework. Here is a Java documentation. We expect you to read those Java docs before you play the game because it will help you a lot. So that's challenge 1. Start. Briefing. Game scene is like a Star Wars style text. Basically, it says you are chosen as a guardian of galaxy. Before you can take the job, you need to earn your weapons. Some sort of crap. You just click accept. Okay. This is the first puzzle. Lock the treasure box. It's a hint. You need to know where collection methods, and you also need to know what's not in the collection.java. And remember those numbers. It will be used later. Let's go to get the password. Here, add to array, add or. Remove the or collection methods. Get is a list method, so 5 is one of the number. 6, this is connection. Lower is not a connection. So 7, 8, connection. 9 is a queue, so 9 is not size. This is 10, 11, remove. This is not a connection method. 12, 13, this is a map method. Connection method, connection methods, connection method. So this is a passcode you need to put and in order to unlock the next scene. Okay, claim your first reward. Here you got 4 goodies. This one, a green lantern. A set, a collection that contains no duplicate elements. This interface models the mathematical set abstraction. Collection. This box you saw before. The root interface in collection hierarchy. A collection represents a group of objects known as its elements. This interface is typically used to pass collections around. And list, an ordered collection. This user can access elements by index. Queue, a collection designed for holding elements prior to processing. And here, since you solved a puzzle, your skill increase, collection set, list queue, and of course you need gain skills for maps. So let's go next. Here is another puzzle. Put your mouse here. Concurrent hash map. Skip list map. Hash table. Hash maps. Linked hash maps. Tree maps. So you know the pattern. They are all implementations of map interface. Sorted map is an interface. It's not a implementation. So let's select it. Check answer. Sure, that's the answer. And it shows you a picture of the map interface. Map interface. So let's go get a reward. Here you get 3 goodies. Map, an object that maps keys to venues. A map cannot contain duplicate keys. A key can map to at most one venue. Sorted map. A map that further provides a total ordering on its keys. The map is ordered according to the natural ordering of its keys, or by a comparator typically provided at sorted map creation time. The order is reflected when iterating over the collection views of sorted maps. Returned by key sets. And here we have concurrent map. So a mysterious crystal chain. A map providing thread safety and atomicity guarantees. So you have to use it correctly, otherwise concurrency can drive you crazy. Okay. And of course you gain new skills for map, sorted map, and concurrent map. Let's go gain more energy. Briefing. Now you know interfaces. Interfaces need implementations to be useful. And so let's start implementations. Let's go. Here is your magic box. All the magic in Java you do in Java you do current map, sorted map, navigable map, concurrent navigable map. Those are the interfaces of map. And here are the interfaces: extending collection interface, set, list, queue. For set we have sorted set and navigable sets. Queue we have deck, blocking queue, blocking deck, transfer queue. Okay, and let's continue. Here read the menu. We have connection interfaces, iterable. Through the iterator, you can get an iterator, and there's methods like next, has next, remove in the iterator. And if you click the image, you get the interface methods for each iterator. Iterator collection allow you to add or remove and check the objects inside, and the block action like size is empty, clear. Here are the list of the interface methods. Okay, set is maps a mathematical set. Remove or is mathematical a minus b. Add or is mathematical a or b. Retain or is mathematical a and b. So here are the explanation. Sets didn't add actual signature besides those in the collection. The Java doc listed some interface methods because they want to have the Java doc specific to the sets. List have index. You can get a particular index value, index of, remove some elements, add elements in the middle. Of course, shift the rest of the elements backward and replace some elements. Here are the interface methods. Queue allow you to Add or remove elements at the head of the collection. Also allow you to inspect with pick. There are two groups of methods. One group throws the exception when the queue is empty. Add or remove element. Another returns special value. Those are the offer, pull, pick. Okay, deck allow you to manipulate data at either head or tail. So the difference is first, lost, and again, there's two groups of methods. One group throw exception, another group don't. And blocking queue. When the queue is empty or full, blocking queue have actual methods to wait for a while or block. So the blocks put take blocks until there is available slots. Offer and pull another version, just blocking for a while until the timeout expires. So that's blocking queue, blocking deck, same thing, except you can manipulate data from both ends, and of course two group of methods. Transfer queue. Last but not least, a blocking queue in which producer may wait for the consumer to receive the elements. We say may because we have methods try transfer with timeout. It only wait until timeout. So those are the major interfaces and its methods. Let's connect next. In this challenge, we want you to put the implementations into its interfaces, the closest interfaces. If you need to check those implementations, you always can come back, check here, interface map, and the implementations of interface connection. So let's try to sort it. Blocking queue is a queue, deck is a queue, array nest is a nest, this is a queue, this is a queue again, and skip nest set is a navigable set, copy on write array nest is a nest, and copy on write, this is a set, hash set is a set. Blocking deck, so this already blocking deck. We want to make the queue more specific. Array blocking queue is a blocking queue. Array deck is a deck. Concurrent linked deck is a deck. Concurrent linked queue is a queue. Okay. And let's bring more queue in. This is a queue. Linked hash set is a set. A linked list is a list. Another queue. Another queue. Okay, this is a full. Let's further sort as it's blocking deck, blocking queue, transfer queue. Okay, this is a transfer queue. Let's put it to the transfer queue. And blocking queue. Put a more queue. Stack is a list. And a synchronous queue is a blocking queue, and a vector is a list. Tree set is a navigable set. Okay, looks like it's good. Let's check your answer. You're right, so get the reward. Here, your third reward. You just get a whole bunch of good weapons, navigable set, concurrent skip nested set. The under list interface you have vector with storm, array list is a little bit smaller stack, old but not obsolete. Copy and write powerful. Under queue you have concurrent linked list queue, priority queue. Blocking queue is priority blocking queue, so it's better, similar. This one is synchronous queue, transfer queue very hot. It's worth waiting. Deck. Okay, array deck. Concurrent linked deck. Our blocking queue is very good. So just okay, you get all those things, and your skill of the collection is almost for 90%. Map, you still need to hone your skills on the maps. So let's recharge the maps. Briefing. Stream and performance tuning is tricky. Debugging comparable. Comparator equals and hash. Concurrency without understanding, crazy. Okay, be warned. Let's go. Yes, I got warned. Let me go. Read the menu for maps. Click images to review the interface methods and signatures. So map, sorted map, navigable map, concurrent, navigable map. And here are the implementations: hash map, linked hash maps, tree map, concurrent, skip list maps, concurrent hash map. Okay, and for the map, we actually can put and get, we can do the replace, and we can remove clear all the elements in the maps and check is empty size. Those are the major methods, and there's 3 views like key set, entry set, and venues. If we click the message, this is a list of some of the Java 8 interface methods, like compute if absent, compute if present, get all defaults, merge, put if absent, those goodies. And sorted map allow you to get the head map, sub map, tail map. The detail is you see key M, key H, the begin is inclusive, the end is exclusive. So just key M, so key M don't include the only include km minus 1. If you check the interface methods, here are the OR key inserted into sorted map must implement comparable interface or be accepted with comparator. Ordering provided by comparable comparator must be consistent to equals if the sorted map is to implement the map interface. We have navigable map, and navigable map allow you to get a senior entry, senior key, higher entry, higher key. And it also allow you to get a first entry and the last entry. Of course, allow you to get the descending map and descending key sets. And let's check the interface methods. The following methods return the closest matches for given search targets. Return now if there is no such key. And the lower key don't include the edge. Floor key includes the edge. Ceiling key includes the edge. Higher key don't. Again, the other group is entry instead of the key. And we go to concurrent map. This one is very annoying sometimes, okay, because you need to notice put happens before relationship between put and get and contains key remove. And some operations not atomic, like those block operations like put or and put if absent for each. So if you forget about those constraints and just use the concurrent map like thread safe, literally you will be regret later. So these are the cautious you should taken before you're using the concurrent map. So we have read the menu. Let's go to the challenge. Click next. Okay, here is the challenge. We have a code This code is actually, the thing is Diablo is escaped from the jail by the help of bar, and you need to finish this code in order to know how that guy escaped. Okay, here is a tree map. Tree map, this is tree map need a comparator, and let's complete the comparator O1 and O2, and this is a comparator. And here the bar have to let's start the code. What happens is the key when you do the compare, you only compare the claw, okay? And if we check the devil class, the core is always 666. So if you create another object with the same claw, tree map consider them the same, and the second one will not be added into the tree map. Of course, the tree map is a jail, so only the bar is added to the jail. The Diablo didn't, so that guy escaped. So what we need is a new devil. Okay, since the new devil have the claw 666, it is added and put Diablo one success, and Diablo is not in the jail. So later when you iterate through the jail and kill the guy in the jail, the Diablo didn't get killed, and so that guy escaped. The same thing for hash map. Okay, hash map. You're trying to put Diablo again. It doesn't work because they have the same claw and is considered as the same, and the equals is also considered the same. So hash map, a different design of jail also skipped the Diablo. That guy escaped twice, and that's how it escaped. Let's try our answer. Sure. You are a success. Go get a reward. Burning. Okay, this is a reward map. Powerful weapon, tree map. Have precision, concurrent hash map, powerful, concurrent skip math, the most powerful. Okay, so that's end of episode 1. After that, you get a bunch of skills. Your map skills not complete, and concurrent map, you still need to study concurrent in order to complete your skill sets. And because the previous thing is kind of hideous, you might don't want to accept. You can optionally click reject, but let's accept, and waiting for next episode. Here is all the things you just walked through. Okay, that's it. XYZ code blogspot.com. Go check out these games.